I'm Eli Wintersheet, and this is Lab 4, Circuits. The purpose of this lab is to examine ideal circuits. We'll be looking at the concepts of resistance, capacitance, and charging or discharging of capacitors. This will be done using a fully simulated circuit. The formulas used in this lab are the potential difference across a resistor, Ohm's law, the potential difference across a capacitor, the loop rule, and charging across an RC circuit. At the beginning of this lab, we made two predictions. The first one, which relates to the circuit shown on the left side, says that I1 and I2 measured on both ammeters will be equal to 0.02 amps. And the second is that the total potential difference across the whole circuit would be 0. So the first observation that can be made is that prediction 1 was correct. Both ammeters show 0.02 amps. And then another observation that we can make is that when the ammeter is flipped as such, it'll still show the exact same thing. Another observation we can make is that when a voltmeter is added to the circuit to create the circuit, the ammeter will read 0 volts and the voltmeter will show 3 volts. And this is because 3 volts is the EMF and the current cannot flow through the voltmeter because how a voltmeter works is it has a near infinite resistance inside of it. The next prediction that we made, saying that the entire potential difference across the circuit is 0, that was correct. When we measured in, I believe, seven different locations and added to everything together, the total voltage was 0, and that can be seen on this here graph that I'm circling right now. Now, when we measured the voltage across different locations, say right here and right here, it doesn't break the flow of current because essentially what we're doing is measuring in parallel. The circuit can still be completed by going through the ammeter or going through this wire, and it's just looped around right here to make a parallel circuit. Now, another question that was posed is what would happen if we added an ammeter in parallel in the circuit, and what happens is the current increases and reads 0.06 because the ammeter now has a new path of least resistance. Instead of what's happening in this resistor, it can go through this perfect ammeter that has no resistance and move faster. And of course, in the last question of this section, it asks what the resistance of each part is, and when we look at the resistance of the resistors, it is the resistance of the resistors. It's 47 and 100, as depicted in the given data. However, the resistance of the wire and ammeters are both 0. Now in the next section we look at an RC circuit in which we have a resistor as posed by these bulbs and a capacitor right here. And so what happens is when we start the circuit, we complete it, the light will gradually dim while the capacitor charges, and we can see the current slows down to 0 when it hits steady state. Now, when we remove the battery as such, and we connect it, what will happen is the capacitor discharges and the current flows back through the resistor, and essentially the capacitor acts as a battery. And so when we timed it, it took about 8 seconds to fully charge and discharge with this 10 ohm bulb, and then it took 16 seconds, about double, to fully charge and discharge with a 20 ohm bulb. Now with this, we used the voltmeter and we hooked it up while the capacitor discharged, and we measured the voltage decrease throughout across the capacitor, and we measured those values and we plotted them in a graph right here. And so what we did, this is just the pure time versus voltage difference, and you can see it's this natural log plot. And so when we take the natural log of this of the exponential plot, we get this nice straight line, and the value of the RC value lines up with the calculated one that we used with the PHET. The questions were posed: what if we used a real ammeter? And so what would happen is we wouldn't get the same results because resistance does exist in the real world. There's no such thing as a perfect wire or a perfect ammeter. So we would get slightly different results. And then again, what would happen if we used a real battery and capacitor? It would take longer to charge up that capacitor due to the inefficiency of the wires. Of course, they have some mild resistance. They would slow everything down. Thank you.